However, there's a lot of new stuff. All right, so synthetic is 6, -4, -27, plus 18, plus 0. Okay, don't forget the 0 in there. And 2 here. Bring it down. 6 times 2 is 12. Add 8. Multiply 16. Add. Multiply. Add. Multiply. And then 1 fewer degree, so this started out to the 4th, so this is the 3rd, plus 8x squared minus 11x minus 4, and then minus 8 over x minus 2. Next one, a 2, a -25, a 66, a 48, divided by -8, which would be a positive 8 over here. So bring down 2, multiply 8 times 2 is 16, add -9, multiply -72, add -6, multiply, and then 1 degree less, so x squared minus 9x minus 6. No remainder. Last one. 5 plus 33 plus 50 minus 8. Divide that by -4 here, so move down, so 5, multiply, -20, add 13, 13 times 4, 52.
Did you do number 4 with after this one?
Yeah.
I forgot how to do it already.
1 degree less, it started with x squared, or x to the 3rd, so it's x squared plus 13x minus 2, no remainder. In doing that one, the biggest thing you got to do you look at the x when you're trying to get into these. So how many times does 5x go into 30x squared?
6x.
6x. Multiply those two and you get 30x squared. And then this times this right here to get this number right here.
You multiply 6x times 3.
-3.
Or -3.
Then do the opposite because we're subtracting there. So this takes care of it, and this is 15x minus 8.
Plus,
How many times does a 5x go into 15x?
It's plus 8, I think, isn't it?
Yep.
Oh.
5x will go in 3.
3 times?
3 times.
So 15x, and then 3 times -3 is a -9. The opposite, because I'm going to subtract it.
Remainders are 17 over 5x over 3.
Yep. You got to kind of break those two apart, and then take the first part into each one, and the other one is you're using to multiply. All right. So today we're going to talk about conics, or cones, and there's several things that we're going to talk about with that. First thing, we're going to talk about asymptotes. It's kind of a funny word. Rational functions and asymptotes. Finding the domain is essential. Where will x and y axis be? And be 0, sorry. And so we're going to watch a few videos here on that particular thing, and we're going to discuss asymptotes. We'll sketch some asymptotes. We'll talk about parabolas. Ellipses. Sometimes asymptotes are called branches. So, for instance, if you look at 230, on 230, down where they have the sketch of it, those two things are called branches. Kind of looks like sticks.
How many chapters?
Huh?
9 chapters?
Yeah, but we'll go through 7.
Oh, cool.
What piece was it?
230.
Those are asymptotes, the separated lines.
Yes, they are. Oh, darn it. That's why.
Is the other lady email you? Says she wasn't going to be here?
Yeah.
Does she still come to class? She still in class?
No, Annette. No, she had a drop. Too much going on.
That's not good.
They're graphs, and those graphs are some of the most interesting.
Okay, so let's start this over. He's going to talk about rational functions first and finding the domain and where it is that the x and y are going to be 0.
In this section, we'll be talking about rational functions and their graphs, and those graphs are some of the most interesting in mathematics because there's a great variety of graphs that come from rational functions. Now, rational functions are composed of a polynomial numerator over a polynomial denominator, like this example. Now, because we have a polynomial denominator, we have variables involved, and those variables can take on values that will cause the denominator to become 0. And if the denominator becomes 0, the entire fraction is undefined. That presents a rather interesting situation graphically, as we'll see in just a minute. We're going to begin our discussion and our investigation of the graphs of rational functions by using the point plotting method. Now, we know that if we replace x with 3 here, we have a y value that's undefined. Now, I have just given a number of other points that we can plot here in our table. I've plotted those points and some others here on this coordinate plane. Now, notice that the graph is curvy right over here, and it's kind of curvy in the same way over here. And it turns out that the last point down here on this curve does not connect with a point way up here. So the graphs of rational functions are very often not continuous. Well, let's see. The graph then looks like this. There's kind of a curvy thing going on. This is called a branch, by the way. This is a branch of the graph. Here's another branch. Now, it turns out that these branches are approaching lines which are called asymptotes. Now, the vertical line that the graph is approaching, the vertical asymptote, is at the 0 of the denominator of our function. Now, that was x equals 3. X equals 3 is here, and that vertical asymptote then is this line. Now, an asymptote just generally is a line that the graph gets infinitely close to at the extremes of the coordinate plane. Now, by the extremes of the coordinate plane, I mean extremely left, extremely right, extremely up, or extremely down. That is, as this graph drops, it will get closer and closer to this line, this vertical line, x equals 3. And as this graph goes infinitely far upward, it'll just snuggle up to that vertical asymptote. We'll see why in just a minute.
So we'll never touch it?
No, it does not ever touch it.
So if you plug x into the equation, you get 0. Or if you plug 3 into that equation, you get 0.
Yep, so your asymptote's gonna be at 3.
And how do you know when you, any equation with a odd exponent will give you asymptotes? No, that's not true necessarily.
He's gonna explain it. You and your
The asymptote
inquisitive questions.
play a role here because the limit is around that asymptote. That is, usually the asymptote is, or the place where the asymptote occurs is the target point a lot of times. So we're thinking about, gee, on the right and left-hand side of the asymptote, does the graph go up without bound or down without bound, and therefore the limit from the right or limit from the left can be determined. Well, when you studied the notion of rational functions, you were taught a lot of times to take this approach, that we know we have vertical asymptotes at the zero of the denominator, so we were taught as the first order of business to factor that denominator. And in this case, it factors to x minus 2x plus 2. So immediately we would march over to the graph and say, all right, we're going to start to construct the graph, so I know that we have an undefined situation for the function when x is 2 or negative 2. So I'll make vertical asymptotes at 2 and negative 2. So
Cannot
we
be
have
that,
a
right?
three-part graph here. Now we'd like to know what happens in this region of the coordinate plane, that region of the coordinate plane, this region of the coordinate plane. All right, that's all well and good. What about the other asymptote? Well, there is a horizontal asymptote involved here. There was a horizontal asymptote in the previous problem. Remember the rule for horizontal asymptote? It went like this, that it had to do with the degree
I know, right?
of the polynomial in the numerator and denominator. If the degree of the polynomials were the same, then you look at the coefficients. And you make a fraction out of these leading coefficients. The fraction is 1 over 1 in this case. 1 over 1 is 1, so we have a horizontal asymptote at 1. Now, when the degree of the numerator is smaller than the degree of the...
Okay, notice that he said first look at the degree of the leading coefficient. I have a 2 on the degree and a 2 on the degree of the bottom one. They're the same. So when that happens, look at the coefficients in front of those. These particular ones is 1 over 1. Because 1 over 1 is 1, 1 divided by 1 equals 1, then your horizontal asymptote is at 1. Okay? If it isn't, he'll explain that too.
Denominator, it turns out that the horizontal asymptote is the x-axis, and that's what happened on the previous problem.
I'm sorry.
Anyway,
I'm upset with how straight his lines are.
Tell me about it. Tell me about it. He also has, if you look, there are lines on his board.
But still, even if I have lines, I'm usually like, woo!
Absolutely.
So that means that you're going to have a parabola in the top middle. And
Possibly.
touch those asymptotes.
Possibly.
Possibly.
You're going to have to do the
First, you have to find the asymptotes.
do this stuff right here. Yes, but then you have to put x. You have to put a number into x to find out what y is, and then plot
turns
your
out that
points.
the horizontal asymptote is the x-axis, and that's what happened on the previous problem.
Sorry, I was trying to get
If
that.
the same, then you look at the coefficients, and you make a fraction out of these leading coefficients. The fraction is 1 over 1 in this case. 1 over 1 is 1, so we have a horizontal asymptote at 1. Now, when the degree of the numerator is smaller than the degree of the denominator, it turns out that the horizontal asymptote is the x-axis, and that's what happened on the previous.
So numerator is smaller than the denominator, is the other one, and then x is your, or 0, is your asymptote there, okay?
So if it's like x to the second over x to the third,
Yes.
and what if it's x to the third over x to the second? What would that mean? I think I lost my house key coming in here.
Why?
I had my phone case. I need to call it. So, got that going for me.
I don't have any problems like that. Where it's higher, yes I do, higher on top than on bottom. That's gonna end up being a slant, but we'll talk about it.
Problem. Anyway, for our study right here, it's only marginally important that we put that in. I'm just adding the horizontal asymptote for completeness.
How about
Now,
you?
when you were graphing these before, if you're graphing by hand, then usually you would choose a point. You just kind of want to know where the turns are in the graph. You know, you out in this region of the coordinate plane in the interval from 2 out to infinity, you suspect that you're going to have a turn like this. Because after all, we know that we suspect the graph is going to snuggle up to the asymptotes at the extremes of the coordinate plane. So it's either like this out here or like this. And it's a matter of where is it on top or below that horizontal asymptote. Well, let's see. We would choose a point out here like 3 and 4 and 5 maybe, or something like that. And we'd say, well, let's let x take on the value 3. And if x takes on the value 3, we can go to either of these forms of the function and evaluate. But if we go to the original form, we have 3 squared 9 plus 1, 10. And then for the numerator, and for the denominator, 3 squared 9 minus 4, 5. That's nice, that's 2. And it works out, since we have squared x's in both numerator and denominator, and no first degree x's, we can make this plus or minus 3. You see, we can evaluate a couple of points here. So for plus or minus 3, the value of y is 2. So over here, if x is 3, y is 1, 2. And negative 3 also goes to 2. Now we know that we're kind of above here, and this just gives us an idea of how close to this corner, sort of, the graph is going to come. I could plot a couple more points, but the idea is that we're behaving like this with the graph. And in this region, we behave like this. Okay. Then what about the middle? Well, we'll choose some points in the middle. Point 0 is right in the middle, so 0 in place of x would cause these x's to go out. We would have 1 over negative 4 or negative 1/4. Let's plot that point. Negative 1/4 for 0 goes about right
Is
here.
it just like guessing?
Now what
things
about
that might-
plus or minus 1?
Yeah.
I hate doing
Or a
this
couple
so
more
much.
points. Plus or minus 1 in place of x. For the numerator here, 1 squared is 1
He
plus
just
1,
takes a
1.
number.
In the denominator, plus or minus 1 squared is 1, 1 minus 4, negative 3. So negative 3. Now we have 1 over negative 3, or negative 1/3. Negative 1/3. Well, we had negative 1/4 here. This would be negative 1/3. I'm not sure I buy into just exactly how this graph goes. Now, I can choose another point. I can choose plus or minus 1.5 if I want to. I can evaluate this on the calculator as well. Or I could say, well, let's see. What about, what if I take kind of an analytic approach and I think about values that are very close to, let's say this vertical asymptote, just to the south side of 2. That is, as we approach 2 from the left, what are we going to get? Are we going to get a big negative number or a big positive number? See, we're just trying to decide whether or not we go this way or this way. And I'm suspecting here, from the way that I've drawn the 1/3 and the 1/4, you can tell that it's going to do a downside turn.
Here's your slant ones.
Here's another one. The approach is exactly the same, and the trick here has to do with the horizontal asymptote. Now, first of all, let's identify a vertical asymptote. The 0 of the denominator is simply at x equals 1. X equals 1, that's right here. And now we look for the horizontal asymptote by looking at the degree of the numerator compared to denominator. So now notice we have a second degree numerator, a first degree denominator. So the degree of the numerator is larger, and that means we don't have a horizontal asymptote at all. We have a slant asymptote. But let me show you how to find the equation for the slant asymptote. That equation is found by simply performing the division that's indicated here and taking sort of the whole part of the whole polynomial part of that without the remainder. Here's what I'm talking about. I want to take this polynomial and divide by this one. I could use long division like this and go through the process, or
Yeah,
I
you
could
could.
use synthetic division by thinking, well, if I'm dividing by x minus 1, then synthetically I'm dividing by 1. And now I use the 1, and the negative 3 here. And remember the process, bring down the 1, 1 times 1, 1, together 2. 1 times 2, 2, together negative 1. That's the remainder. And what I want is the polynomial described by those two items. And that polynomial is simply 1x plus 2. So the line y equals x plus 2 is a slant asymptote. So we can come back over here and draw that line if we want to. Now, notice it's in the slope-intercept form for a linear equation. And the intercept is at 2, and the slope is 1. Now, for a slope of 1, that's a rise of 1, run of 1. And from this point, rise 1, run 1, and so on. So we have points out in this direction. And then in the other direction, we can generate points
See
as
the,
well.
you can see the,
Now, the dotted line then describes
Squares.
our slant asymptote, and if we plot a few points, we'll understand the behavior of the graph around these asymptotes. Let's see what happens. I made a table of values here,
His sine
and
is bigger.
0 goes to 3.
Say again?
If his exponent on the top is larger than the bottom, you take the bottom divided by the top.
And
It's
take
synthetically
that-
possible, if not long division.
yep,
And then, what is it, what do you do with the remainder?
nothing.
Oops, 0 goes to 3. I knew it couldn't possibly be right on top of the asymptote. 0 goes to 1, 2, 3. And negative 1 goes to 1.5. Negative 2 goes to 1/3. And you see the graph is just kind of real tight on the asymptote here, and then it's going to just blast upward here. And we can go ahead and graph that because my other 3 points are on the other side of that vertical asymptote. So I know that on this side, this is what's happening. And I get closer, closer, closer as I go out this way. All right, 2 goes to 3. Then 3 goes to 4.5. We're getting tight on that asymptote already. 4 goes to 5 2/3. So it's kind of like this. Now notice that they look to be really close on that asymptote, and then the turn is made, and it just kind of drops down like this. So the graph, whoops, the graph looks like this. Let's take a look at this one on the calculator.
Okay, so really close to the dotted line without touching the dotted line. All right, just as a review here. To find the vertical asymptote, find out how to make that denominator 0, okay? Whatever that is, like if it's x minus 3 and your x is going to be 3 to make it 0, then your vertical asymptote is at 3. Okay?
So the denominator is the vertical and the horizontal is the numerator?
It's comparing the numerator and
Oh,
denominator.
yeah, it's comparing.
Yep.
If the signs are the same coefficient, if one of them, if the top one is smaller than the bottom one, 0, x is 0, and then if the larger one is bigger, divide whatever
Whatever
new polynomial is.
your y equals mx plus b is. Okay.
I should probably write that down and take a note, but
Well, do these two for me. Find the vertical asymptote and the horizontal asymptote.
um, quadratic formula negative b plus minus radical b squared minus 4ac over 2.
Okay, so on this, first of all, I've got to find out where is my x is going to be 0. So x minus 3, x plus 2 should be what my factored issues are there, so, or places are. So 1 will be x equals 3, 1 will be x equals negative 2. Right there. Right there. The vertical one, this is x squared and this is x squared, so they're the same in degree here. Looking at coefficients here, they're the same there, so my vertical asymptote is at 1. Or I'm sorry, my horizontal. Same thing with bottom. X plus 3. X plus 1. So x is negative 3 and x is negative 1.
It's numbers that when you multiply them together equal 3 and add them together equal 4.
Yep.
Okay. I just remembered how you factor.
And this one is a 3x squared. This one is an x squared, so they're the same degree. So I look at the coefficients, so here and here. So 3 over 1 gives me a horizontal asymptote at 3. Now then, I've got several spots that I could go in. There should be could be something here. There could be something there. Probably not there, but could be. Could be something here. Could be something here. Could be something here, and could be something here too. Okay, so that's why we have to plug it into the XY and plot our points and get them connected. Most generally, you're just going to sketch that asymptote or those branches around those spots. Here's some others. Just sketch those asymptotes for me. X minus 2. What'd you say?
Just, I completely forgot everything we talked about.
You just factor the bottom number.
You can't factor the bottom number.
So 2 would be the vertical.
2 would be
asymptote.
your vertical, because if x is 2, then you get a 0.
Your horizontal asymptote is
Okay,
1.
there's no degree on the first one,
That is right.
so the degree is higher on the bottom than is on the top.
So it would just be 0
Would be 0
on
then.
the top and then 2 on the bottom?
No. Your asymptote will be 0 if that's the case. Remember, if it's higher degree on the bottom, then your asymptote is 0.
higher on the bottom with 0, and it has to have an X on the top to be considered.
Right.
Okay. What, do you have X over 1? What would that mean? I mean, it would be higher on the top.
Yep. So that's going to be a,
Would you have to take that, divide it by
it's going to
something?
be y equals x. Right? You're going to have no slope.
Yeah, that was a dumb question. So vertical will be 2, 0, and that one will be horizontal 0, vertical -3. That one will be, your horizontal will be 2, and your vertical would be
Same situation. Higher on the bottom than on the top.
higher on bottom,
So it ends up being 0.
0.
At 0.
Okay, so higher on top. That's good. You tell me your horizontal is 0.
Yep.
Are you on the last one?
He's on the second one.
Honestly.
I was on the second, the last one. 2x plus, or 2x minus 1 over x.
Now you're on the last one?
Yeah.
I'm sorry.
So that would be
So what would make that x 0?
0.
0. So your vertical is 0.
And your horizontal is the larger coefficient on the top.
Nope.
It'd be negative.
Coefficient, but not degree.
They're both the same.
They're both the same, so then we look at coefficient.
Yeah.
So where is it going to be?
2 over 1.
2 over 1, which is 2.
over- Yeah, 2.
Absolutely.
Are you talking about like when you say horizontal and vertical? Are you talking about the 2 x's that equal like from the one we just did was like x equals 3 and x equals -2, like up on the board?
Yep. What about these 3?
Oh, God. What are you going to do that for?
Because you're going to have it on homework and then the test too.
Oh,
Who
God.
decided that we needed this?
How many questions are on this test?
That's a darn good question. I can let you know when we're finished.
Oh, there's like 49 questions on this homework?
I don't know.
That's a lot less than
A lot less than
70.
normal.
Like, I forgot we had math homework until last night, so I was working on it while I was at work.
Ouch.
I forgot and then I got like
Well,
75 49, so 39.
I got it to a 76.6 with the last 15 problems I could not figure out. My brother had no idea. And they had, one of them had like practice another version, then you click it and it said no other version is available.
Yeah.
I'm just like, fine.
Yeah.
Well, that wasn't very nice of them.
I know.
Or it has the one problem that's like that, and it doesn't give you like watch it or practice another version. So it's like the very last one, I was like, I didn't know what this is. My brother didn't know what it was, and I was like, okay.
So the top one is easy. The vertical asymptote is -1.
Okay?
And then the horizontal asymptote is going to be 2 because the variables are the same for the exponent. I mean, the exponents or the powers are the same. And the coefficient is 2 over 1.
Absolutely. That's
But
correct.
Then we get to the bottom one. And that one is just all sorts of fire trucks up. We got-
Well, let's look at what, okay, first of all,
we got
first of all, we have to factor that bottom number.
So that's going to give you two numbers multiplied together that equal to, when are added together, equal 1, -1.
-1. Mhm.
So you're going to have -2, +1.
Correct.
X equals +2, x equals, x minus 1.
X equals -1. Yep, you're right.
So x,
So 2 and -1 are my vertical asymptotes.
x minus 1.
Can I
Or-
have you write down what he's saying so I can write it on my notes? Because I'm having to
Yeah.
with him.
Oh, I'm
You're on.
Because I only make sense to myself if I talk it out.
Well, my thing is like I can't tell when you go to the next problem. It's like,
He's on the second one now.
Yeah.
So we have talked about, he tells me that there are two asymptotes, one at the 2 and one at the -1 that go
Other way.
vertical.
Other way around. -2, +1, right?
-2, +1,
Yeah.
yes.
Okay.
Now he's looking at the degrees, and we see that it is a lower degree on top than it is on bottom. What does that tell me?
That tells you that we gotta do a synthetic division. But we can't, because there's no coefficient.
No, it has to be higher degree on top for that.
Oh. Well, that tells me it's 0.
what are you
0.
looking at for the degree?
X is a degree of 1,
Mm-hmm.
and x squared on the bottom is a degree of 2. Because the x squared, it's got squared.
So it's x to the 1 power up on top.
We're looking at the exponents.
On number 2. Anytime that x by itself is to the first
I
power.
was looking at the first one. I was like, it doesn't have an exponent. What are you talking about?
Yeah, that was
There's nothing
interesting.
there.
That would help if you're on the right one. Okay, now we're going to talk about the third one, Rihanna.
Okay.
And then this, on the top one, I tried to throw you off by rearranging it.
Yes, they did. Yep. Okay, the third one. Factoring the bottom numbers, or the bottom polynomial,
You know the horizontal is 0. Right? Because it's first power over second power.
it is.
So that's 0. Can't dip below 0. So factor the bottom, it's just the same as the top almost. So-
Almost.
But so it's +2, -1.
+2, -1.
So
Okay.
those are your asymptotes there, and then we know horizontal 0.
Actually, it's not +2, -1 as an asymptote,
Positive.
because we have to set x equal to 0. So +2 and -1, x +2, x -1. But when we set it equal to 0, then those change the opposite.
Oh.
So it'd be -2, +1.
Oh, okay. Okay. Yeah, -2, positive. So
Yeah.
at the top it would have been, you were right. You said +1, -2 or something like that. You said it right, and then I was like, are you sure? And you're like,
Yeah.
I give, okay, so you just flip flop them when you're
Yep,
factoring?
because you put x +2 equals 0, and then when you move the 2 over, then x equals 2.
Mhm.
All right, so there's that one. More of the same. All right, what about these?
Well,
Degree is higher on top.
yep. So you're gonna have 1/1.
That's the whole one.
X equals 1. Yep, so we have a vertical asymptote at 1 on the first one.
It's 1/12, second power, first power. So that's larger. So now we're gonna have to synthetically divide
Absolutely.
x squared minus x minus 2.
So 1, -1, -2 inside the box, divided by +1.
So 1, -1, -2 divided by +1.
+1, yep.
1, 1, 0. Wait a minute. Hold up. Wait a minute. Something. X plus 0, remainder -2.
Okay, so x plus 0 is all you need. You don't need the remainder. So y equals x. How do I draw that?
Y equals X.
Where's my b, or where am I crossing over? The y-intercept?
Oh, because yeah, this is the slope one. Mx plus b, so 1. 1 is your slope. You're gonna have a.
Your slope is 1, that's correct, but where do you cross over the y-intercept? I don't have one of those numbers.
0.
0. Okay, so up at a 0, go up 1/1, draw my line.
0, 0, 0, up 1/1.
Yep.
Up 1/1. Alright, I'm would definitely not remember that on but I will
I'm like,
get it on a separate view.
I'm a visual learner. I learn so much better when it's broken down. So.
What
Oh,
are the
okay.
vertices of a hyperbola?
Not there yet.
Okay, okay. But it looks like what we've been working on, but it's definitely Is that even a word?
Yeah.
F-O-C-I?
Yep, foci.
Foci? What?
Focus. Okay, parabola.
The plural form of cactus is cacti.
Absolutely is.
That's weird.
For a parabola. Now, we've been talking about parabolas for a while. It's the, the U-shaped or the upside-down U-shaped. The foci or the focus is a fixed point that is inside of that, most generally inside of that. Look over on 242.
Is foci the plural form of focus?
Yes. You see the foci is inside of those parabolas there? A little bit inside for 4.18, a whole lot inside for 4.19. The directrix is a fixed line. You see that on 4.18? That's the dotted line there. Y equals -1/8. Standard equation of a parabola is x squared equals 4py. P not equaling to 0. And y squared equals 4px, where p does not equal 0. The first one is where it's going to go either up or down, and the second one where y squared is going to go sideways. Okay?
What? I know.
On the y squared ones, if you look at 4.19, you see a y squared equals 8x. It goes sideways instead of up or down.
Okay, and an x squared.
Yep.
Anything x squared is going to open
Can you go back to the house?
Yep.
vertically, and anything y squared is going to open horizontally.
Yep. Okay, so the biggest issue with this here, and in fact I had the online group did this last week. You have got to find a place that this is going to be 4. Okay, so if I have y equals -2x squared, my equation here is actually supposed to be y equals 4px. Okay? Because the term is squared in the x, we know the parabola is vertical. Okay? So this x squared tells me that it's going to open either up or down, not sideways. Okay? So I'm going to put in this. Actually, I've done that already. Divide each side by -2 to get x by itself. Okay, so y divided by 2, or 1/2 y, equals x squared. And then I want to put it in standard form of this right here, x squared equals 4py. All right, so 4py, when I do that, I've got to have this right here be my answer, whatever it is. Okay, so if I take 4 times 1/8, then I get 1/2. Okay, so that's why, actually -1/8, because I have a negative
Are
here.
those like pairing equations or anything? That y equals -2x squared? Or is it just a random equation?
Just random.
Okay.
So P is -1/8, because that's what this is right here. 4 is just part of this particular equation right here. And I've got to have it equal to -1/2. So that's why I take 4 times, well, what I really did was I took 4 times negative 1/2. And that gave me negative 1/8. So I know that this here, P has to be negative 1/8.
Where'd the 4 come from again?
Yeah, that is my equation. 4px.
Where is the P, what does the P mean?
P is where you have the focus point. P for point. Okay, so if P is negative, the parabola opens downward. Okay, so here is I know it's going to open downward, and this foci point is 0, negative 1/8.
So how do you go from negative 2x squared equals y, you divide that by 2, and that gives you x squared equals negative 1/2 y.
Uh-huh.
How do you get x squared equals 4py?
Take 4 times negative 1/2.
Where does the 4 come from?
I still don't know what the 4 is coming from.
That's the point it tells us.
That's your standard equation.
That's the standard equation.
Standard equation. So what you do is you take that negative 1/2 and you take it times 4. That will tell you what P has to equal to get that to be negative 1/2.
What exactly is the point of focus?
That's where it is going to, it is, what it is it is a point, my guess is on this one, the director is going to be at negative 1/8, and the parabola goes in between those two. Foci point, see what the definition actually says. Well, I'm looking at ellipse and the foci is on there. See if there's something over here that. A parabola on 241. A parabola is a set of all points x and y in a plane that are equidistant from the fixed line, the directrix, and a fixed point, the focus, not on the line. Vertex is the midpoint between the focus and the directrix. Okay, so the top of that parabola is in the middle of there. And the axis tells me how it is that is going to show. Either be up or down or side to side. Over on 243, the foci for an ellipse is, again, a fixed point. And really if you look at the ellipse, the foci there is in between the center of that and the outside of it. So really the foci is a point that tells you about really where the middle is. So this one here is the middle of that parabola between this directrix and the top of the parabola. Why do I need it?
Is it gonna be on the test?
Probably. Just remember the equation there, and that is in the book, by the way. This right here.
What was this invented for? What is its use?
Say again?
What was this invented for, besides to confuse people?
Just because then you know exactly where that, like this particular one, where that parabola goes in between that line and where the top of it is.
What are we ever using this?
My buddy was telling me that calculus is more practical than college algebra. He says once you take calculus, it kind of like everything comes into place.
Should solidify everything.
Yeah.
But you're not ever going to take calculus.
In theory, I don't think so.
Yeah.
My brother took calculus for fun.
See, that would be something I would do.
He didn't even need it. He's like, oh, let's do the class.
So why would you take calculus if you don't need it? If all you need is statistics. Speaking of statistics, I am teaching that in the summertime, in June.
How much is that class cost?
Your normal
I got two school
I don't know if we'll have student aid by then.
That's a good question. You might be able to work that out though,
Okay, I'll look into it.
but it's 3 hours and it goes through the month of June. 9 to 12, 9:30 to 12:30, something like that.
1 day a week.
4 days a week. Monday through Thursday,
And it's all June.
all of June.
That's it?
Yep, that's it, that's it. That way you have a summer. All right, find the standard form of the equation of the parabola with the vertex at the origin, 0, 0, and the focus at 2, 0.
Find the standard form of the equation. Parabola vertex at the origin. See. Alright, so. Vertex at the origin and focus at 3, 0.
So we found the focus right here. So work backwards.
Okay, so we need to.
2, 0, right?
Mhm.
And this was x squared equals this. So it's going to be a y squared equals something, x something. And this is 2, 0.
Y squared equals x.
Yeah, because we had x squared over here.
Okay.
And so we want y squared, or I'm sorry.
So we started out with y equals negative 2x squared, and we got 0, negative 8, negative 1 over 8.
So where x is 2,
oh gosh, I like. So.
yeah,
What does this help you find on the equation? I guess I don't understand. Because you're going to find your vertex or your parabola. You can find that pretty easy to think. I don't know how. It should be easy.
my point is this 2. All right, so let's watch. Not this one, but the next one underneath of it, 242. You see the same thing really, except for I have 0, 3/8.
How do you know whether an equation has asymptotes? Do they all have them?
Yes, they should.
So this video will be the second equation on the thing.
Yes. Come on.
The axis of the parabola is a vertical line passing through 0, 0, and 0, 3/8. So the graph will look something like this. Because the parabola is vertical, you know the standard form is x squared equals 4py. The focus is the point 0p. So here, p equals 3/8. Therefore, the standard form of the equation is x squared equals 4 times 3/8 times y. Multiplying 4 and 3/8, you can simplify this to x squared equals 3 halves y. So the equation of the parabola with the vertex at the origin and the focus at 0, 3/8 is x squared equals 3 halves y.
Oh, that was like, yeah.
Find the standard form of the equation of the parabola with vertex at the origin and focus at 0, 3/8. The origin is the point 0, 0. Because the axis of the parabola passes through both the origin and the focus, you know that the axis of the parabola is a vertical line passing through 0, 0, and 0, 3/8. So the graph will look something like this. Because the parabola is vertical, you know the standard form is x squared equals 4py. The focus is the point.
Okay, so we know it's vertical. It shows you that, right? So she uses x squared equals 4py, and p is 3/8. So just replace p with 3/8, multiply it times 4.
0p. So here, p equals 3/8. Therefore, the standard form of the equation is x squared equals 4 times 3/8 times y. Multiplying 4 and 3/8, you can simplify this to x squared equals 3 halves y. So the equation of the parabola with the vertex at the origin and the focus at 0, 3/8 is x squared equals 3 halves y. Find the standard form of the equation of the parabola with vertex at the origin and focus at
I don't know where that
0,
went to.
3/8. The origin is the point 0.
So she puts because the graph opens vertically, she puts p at the y value. The y value is 3/8. She puts 3/8 as the p value.
Yes.
Okay. And if it was open horizontally, you do
That
the
would
same
be in the
thing.
y value. It would be the opposite.
X value goes in the p
Yeah.
value.
All right, so let's go ahead and talk about ellipses. I know parabolas didn't really, that standard form of equation kind of gotcha, but let's go ahead and talk about ellipses. Ellipses aren't too difficult. Actually, I kind of like them. An ellipse is a set of points, x and y, in a plane, the sum of whose distances from two distant focus points is constant, and the line through the foci intersects the ellipse at 2 points or vertices, their major axis. Here is the way you will see them. First of all, horizontal. If it is horizontal, you will have x squared over a squared plus y squared over b squared equals 1. If your major axis is vertical, so it is elongated up and down, you will have x squared over b squared plus y squared over a squared equals 1. See the difference in where the a and b places are. Okay? So let's talk about graphing in ellipse. I'm having issues here with my
another graph of this equation. We recognize it as the equation associated with an ellipse because we have an isolated one over here. We have a plus sign between the two fractions, and the coefficients of the two numerators are 1.
Just for a little bit more information, A is always the bigger number. Okay.
What are those A and B doing?
Well, one of them is 16.
I mean, what are they stand?
Say that again.
What does A variable stand for? What does B variable stand for?
A stands for the bigger number, B stands for the smaller number, and then it's going to depend on which one is first or second here. This has B squared first, so your ellipse is going to be vertical as opposed to horizontal.
Where do those values come from? What do they mean?
If you look on the standard equation of an ellipse, 243, there are two of them. Major axis is horizontal if A is first.
Okay.
Major axis is vertical if B is first. And again, A is the bigger number. Okay? I think it'll make sense once we look at it, all right?
And we have x squared and y squared, of course, in those numerators. At any rate, we want to identify the values for A and B. We look at our two denominators. We notice that the larger of the two is under y. That tells us that our elongation is going to be vertical rather than horizontal. We also know that the number that is squared to give 25 is going to be the A value. A then is 5. The B value is found here as the number squared to give 16, so the B value is 4. Let's draw the graph. A is 5, and we're elongated vertically, so we go up 1, 2, 3, 4, 5, and then down 1, 2, 3, 4, 5. And our minor axis is horizontal. The B distance is 4, so from the center we go to the right 1, 2, 3, 4, and to the left 4. And our graph looks about like this. At this point, if we want to, we can find the value of C and actually construct a graph of those focus points. Let's do that. Now, with A and B, we use the relationship between A, B, and C in order to find the value of C, the distance from the center to the focus points. A is 5, B is 4, 5 squared, 25, 4 squared is 16, 25 minus 16, 9. So C then is plus or minus the square root of 9. All we need is the positive value here, so C is 3. So we come back over here, and along our major axis, we go a distance of 3 from the center. So we go up 1, 2, 3, and down 1, 2, 3 for our focus points. Here's another one. Now, this equation is not in the form that we want it in. We can't identify A and B in this form, so we need to rewrite it in the proper form. Now, to do that, the most important feature is the 1 isolated on the right side of the equation. To accomplish that situation, we'll divide through the equation by 4. So we'll write this as x squared over 4, and then 4y squared over 4, and then 4 over 4. Now, I'm going to emphasize the fraction idea here in this second fraction. You know, this is just y squared because the 4's cancel. But I'll emphasize the fraction notion because we need the information in the denominator for graphing purposes. And on the right, we have 1 as expected. Now, we look at our two denominators. This denominator is the larger of the two. So we know that we have an elongation horizontally. Major axis is horizontal. And the value of A can easily be identified as the number squared to give 4, and that would be 2. And the B value then is 1. And now we can sketch the graph.
Okay, see what he did? It equals 4, it has to equal 1. So we just take and we divide everything by 4. Once he did that,
When that constant is by itself, you have to have the constant by itself first. That 4, you have to have it on its one side of the equation
Yeah.
by itself. Okay.
once that happens, then 4 over 4 gives me 1 as the equals value. 4y squared divided by 4 gives me y squared. And x squared divided by 4 gives me that answer there.
So, an x value that is larger
Yes?
is elongated horizontally,
Yeah?
and y value squared, which is larger, is elongated vertically.
Right.
How did you get 2 and 1?
4 square root of 4 is 2. Because remember, it's going to be a squared.
Why does he take the square root of 4? What is he trying to?
Because you're going to have a squared underneath there. And 2 squared is 4.
Oh yeah, because the values. Okay.
Yep. Are you ready, Rihanna? Okay.
What chapter?
If we have an A of 2, then we go 2 in both directions horizontally. And the B distance is 1, so we go up and down 1 to get to the ends of the minor axis, and the graph looks like this. Now we'd like some information that allows us to graph the focus points. Well, let's use our information about A, B, and C. So we can come back up here, and let's see. We know that C squared is A squared minus B squared.
And there is your formula for your foci point. C squared equals a squared minus b squared. Okay? So in this instance, c squared equals 4 minus 1, or square root of 3.
And A value is 2. The B value is 1. So we have C squared then is 4 minus 1. Since C squared is 3, C is plus or minus the square root of 3. We only need the positive version. So C then is approximately 1.7. I should put approximately equal to here because it's not an exact value. It's an irrational number. But it's good enough for our graph. C is 1.7, so we go over 1.7 in both directions along the major axis and identify those positions.
And that is ellipses. A little bit easier than the parabola when we're talking about foci points and all that. Okay? So let's talk about hyperbolas. Okay, when you talk about hyperbolas, it's a set of points in which a plane in the absolute value is the difference of the distances from two distinct fixed points called the foci. So this one, before when we had ellipses, that was x squared plus y squared. This one is x squared minus y squared.
That's for ellipses. This is for hyperbola.
Hyperbolas. And notice a squared is always goes first there. A little bit different than the ellipses. If you look at 247, slant asymptotes are very important to these, or can be. There's two different ways that we can graph these, and I'll show you them. Actually, Mr. will.
So x squared over a squared minus y squared over b squared.
Y squared, x squared over a squared minus y squared over b squared.
Equals
1.
1. That means that is going to be a larger horizontal stretch for the parabola.
If you look on page 246, at the bottom, those two pictures, you see the difference there?
Yeah, open vertically versus open horizontally. Okay.
So x squared opens to the outsides. Y squared being first opens to the up and down. Okay?
Okay.
And I have two videos on this one.
we're doing the whole chapter 4.
And we know that with hyperbolas, the a value is in the first denominator, and it's the number squared to give that number. The number squared to give 1 is 1. And the b value is the number squared to get 9, and that would be 3. All right, so we can identify them right away. Now, we have a center involved in our hyperbola. The center is at hk. H and k are numbers that follow minus signs. The h is associated with x and the k with y. Now, the number that follows the minus sign here is -3 because we think of this as y minus -3. So the center is at 2, -3. Let's identify that point on the coordinate plane. 2, -3 is right here. All right, now let's think about how we're situated, whether the branches are left, right, up, or down. We have a fraction here. The first fraction involves x in the numerator. So we're talking about a horizontal distance. And so our transverse axis is horizontal. So all of our distances are going to be taken horizontally from that center point. Now the a distance is 1. So we go a distance of 1 in both directions from the center to identify vertices. Now these are points that are on the two branches. The branches are going to be like this. Now we're going to complete the graph and we're going to identify coordinates of vertices and foci. And there's just so much wonderful stuff to do. I don't know what to do first. We can identify the vertices by simply looking at the coordinates of these points. Or we can take kind of an algebraic approach. If we use the geometric approach, we just identify the coordinates of this point as 1, -3, and this point is, let's see, 3, -3. So 1, -3, and 3, -3. Now, the other way to think about the coordinates of those points is like this. We're actually calculating the coordinates of these points from the coordinates of the center. And since all of these points lie along a horizontal transverse axis, the vertical distance is going to be the same for all of those points. That is, for the center point, for the vertices, and for the foci. They all lie on the same vertical distance from the x-axis. And that vertical distance is -3. So that vertical distance is not going to change. What's going to change is the first coordinate for that center. That's the emphasis here. So the idea for calculating vertices algebraically is to take the coordinates for the center and just add or subtract with one of the coordinates or the other. And we need to add or subtract with the first coordinate. So it would be found as 2 plus or minus a. And then the other coordinate is -3. And since the a value is 1, it's 2 plus or minus 1, -3, and we get these values as expected. Okay, for the foci, and
I'm actually going to stop that.
My brain is on fire.
Is it?
Yeah. I am
It's just static.
completely lost. Do we have 2 weeks for this chapter?
Nope.
No? Oh.
Does it do this one?
It will be.
All this is?
49 problems.
It's not.
God.
I thought,
June 24th?
yes, ma'am. See, that's not giving me what I want.
I don't know how to do any of this homework. I'm looking at it all right now. And I am completely lost.
Okay, so say